At Deusser, we have developed and implemented two solutions for the Asphalt use case. One is focused on improving the efficiency of the Asphalt plant's burner, while the other enables predictive maintenance for sensorized components within the plant. The platform is user-friendly, providing easy access for different user roles, and includes links to the project's website. Have you ever needed to improve energy efficiency in aggregate drying cycles? Deusser has created a software based on artificial intelligence that allows us to calculate, depending on the input parameters, the power at which we should set the dryer burner to obtain the highest possible energy yield. Imagine you are a plant operator and you want to be able to view historical burner efficiency data, grouped by date and drying cycles. So in the interface we can access the historical data of the drying process and filter by dates. In addition, you also want to be able to adjust the dryer burner to obtain the highest energy efficiency, that is the lowest possible consumption for a given production. No problem. In the interface we can insert the values of the cycle that we want to optimize, and it will return the prediction of the power that we should give to the burner to obtain the highest efficiency. Now, you are the supervisor of an asphalt plant, and you want to be able to see the historical data of the burner efficiency. Again, in the interface we can access the historical data of the drying process and filter by dates. And also to be able to see the KPIs that tell me how the solution is being used. So, in the interface we can access the two KPIs that are being monitored in the solution. Finally, think like a data scientist. You want to evaluate the model metrics so that you can see how the algorithm is performing and, in case it deviates from its accuracy, be able to retrain it with the new data ingested. Cool. In the interface we can access the metrics that are evaluated in the model and see if any errors are occurring. Do you need to know, well in advance, if any of the motors in your asphalt plant are going to fail so that you can take the necessary corrective actions to avoid production downtime? From Deusser, we have created a software based on artificial intelligence neural networks that allow by ingesting data provided by the vibration sensors previously installed in the engines, to anticipate with enough time a possible failure of these elements. Let's do it again. As a maintenance technician, I want to be able to observe the history of the data from the vibration sensors to be able to have a more technical perspective on the operation of the engines. In the interface we can filter by date and time and view the vibration data, as well as shock, crest and temperature of the sense bearings. In addition, I also want to be able to tag an actual failure of one of the monitored elements should it occur. In the interface we can filter by date and time the data to find the time of the actual failure, and we can modify the alarm to teach the neural network when the anomaly has occurred. As a data scientist, I want to evaluate the neural network metrics so that I can see how the model is performing and, in case it deviates from its accuracy or increases an error, be able to retrain it with the new data ingested. In the interface we can access the metrics being evaluated in the model and see if any errors are occurring.